Okay, so the contest had started. Let's see what are the problems. Okay, I have not registered yet. Okay. Okay, you are given a string S and an integer k. Reverse the first k character of the string and return the resulting string. Is there any follow-up? No. Okay, k is always going to be less than the string length, so it should not have any other edge cases apart from this. BCD ZYX HEY. We're given an integer array nums and an integer k. Return the minimum length of the subarray whose sum of distinct values present in that subarray is at a list of k. No subarray exists, return -1. A subarray is okay. We need to return the minimum length of a subarray whose sum of distinct values subarray is at least k. So if we need the minimum one, then we should select the elements that are of greater value so that the sum of the elements inside that could be minimum. Okay, we can use sliding window over here. Yeah, we are going to use sliding window. We are going to keep track of all the element in the window by using this queue. Let's say current sum will keep track of the sum of the queue, and yeah. For each of the element, should be the output for the example test cases 2, 2 and 1. B, A, C, D, Z, Y, X, A. Okay. Output is 0. Okay, we need to give one edge case. If we are not able to find any valid size of the queue, then we need to return -1. If main lane has never been updated, okay, we need the unique element, not all the element. So if either of these two is true, then we are going to pop that one element and we are going to decrease the count of that. So we are going to remove all the elements that have been repeated previously, that is present in the front, because those are not necessary, and we are going to reduce the current sum only if it is a unique element. So output is 2, 2 and 1, 2, 2 and 1. Let's see what happens. Okay, it is accepted. The first one is done. What about this one? Okay, it is also accepted. Let's see the third one. N equal to 10, restriction different. Restriction and an integer different length and -1. Your task is to construct a sequence of to return the maximum value of a sequence. And what is going to be the sequence? You are given an integer n, a 2D integer array restriction, and an integer array diff of length n minus 1. Your task is to construct a sequence of length n denoted by a such that it satisfies the following condition: a0 is 0, all the elements in the sequence are non-negative, so all of them has to be greater than equal to 0 for every index I. Absolute of value of any adjacent element will be less than equal to difference of the ith element. Okay, so diff has a size of n minus 1, that's why. For each restriction I index in max value, these are the two values that are going to be there in any ith index. The value at position I index is must not exceed. Okay, so these are the restrictions that we have. So each of the element, like there are some indexes that have upper bound. A restriction could be of any length, right? Yeah. Yeah, it could be of any length. Between 1 and n minus 1. Okay. Okay, because a0 is always going to be 0, that's why n minus 1. Maybe no restriction for the 0th element. Your goal is to construct a valid sequence that maximizes the largest value. Your goal is to construct a valid sequence that maximizes the largest value. Okay. The largest value is going to be returned and we need to maximize it. Okay. But we can't maximize it because they have set a upper bound. So we need to work around that only. Okay. Let's take the first one as an example. First one or the second one? Let's take the first one. So restriction of index 3. So which one is index 3? Is index 0 best or 1 best? Okay, it is 1 best. So this index could have a max value of 1. This index could have a max value of 1, 4, 5, 6, 7, 8. No. 0, 1, 2, 3, 4, 5, 6, 7, 8. It was supposed to have a max value of 1. What is happening? 0, 1, 2, 3, 4, 5, 6, 7, 8. Okay, so this is the sequence, right? 0. Okay, this is the sequence, not this one. So the 0, like 0, 1, 2, 3, it has a value less than equal to 1. 4, 5, 6, 7, 8, it has a value less than equal to 1. So 3 and 8 has a value less than equal to 1. So it is a valid sequence based on the restriction. What about the difference? So it starts from 0. It could have at max 2 difference. So that's why we have taken the biggest value that is possible, that is 2. And then we have taken another biggest possible value 4. Then there is a absolute value of 3 that is possible. Okay, but what if it was not 3, it was supposed to be 2? Then this 2 could not be having a difference more than 2, so this element would come up to be 3. So we should start from the restricted element. That should be our starting point. This is supposed to be 0, and then moving gradually towards the bottom. That should be the approach. Now, since the upper bound has been already decided, so what are you going to do? We are going to select the least value that have been given as a restriction. Since there can not be any value lesser than that, so we are going to choose that one, and we are going to gradually move to this one. Suppose instead of 1 there would be 2, so it would be checking if 2 is possible or not. If not, then that should also get restricted to 1. Yeah. We're going to keep track of this in an array. Suppose we're going to take one away. Let's see Suppose instead 30 is true. From 4 to 1. Okay, so we'll keep increasing the value at as much as we can, and whenever we encounter a situation like this where we have to decrease the value, we are going to check how much you need to decrease. Until now, whatever the result we have like we are able to come up with, we are going to reduce that by that number. Makes sense, right? Yeah, I think that's the approach. Per pound. And let's say vector of it. So int max means no restriction, and if there is any restriction, it will be there. So max till now is 0. And index is going to be 1 for auto. So current value at index is going to be current previous is 0 because previous was the index. 0's value be equal to we are trying to add the value, right? But before adding, we need to check. If we are already exceeding the up, if up, and less than the value I got till now, then what we are going to do? If it is already exceeding the value that we are supposed to get over here, then we are going to check if we can come to that value. If that extra that we have that is less than equal to difference, then no issue. Then current will be the least restricted value, and if that is not the case, then also current is going to be the least value, but again we are going to reduce our maximum. We are going to reduce the maximum value between these two intervals. Suppose there is a maximum and there is a maximum. If we got the maximum value over here, no need to check over here, right? So that is going to be the answer. That is also going to be 0. This will actually not work. What is the constraints? In game we have to identify. No, it is not going to work like that. Why? Because suppose there is an array. Suppose we are going to relay we are getting restriction over here. So all this could have lesser value, right? But what if we are coming from here and then we are going to here, and here we were supposed to have a very less value, and this hole was not supposed to be there. So this peak right here was not supposed to be there. For a range, if we are using topmost value, but we were supposed to use the bottom. Suppose this one and the upper bound like this. We are supposed to fill that point. One way could be like this: the maximum value that we can get from left, the maximum value that is possible from right. Out of these two, what is going to be the difference? Starting from there, I will have to get nice. Suppose so at each of the restriction we are going to check what is the minimum of maximum value coming from the left, maximum value coming from the right, and out of all the value that are going to get from each of the point, not from each of the point but from each of the index. What we are going to do, we are going to take the minimum of those values and then we are going to say that okay, that is the maximum. Does that make sense? No, because even if there is something like this, where we are supposed to get the minimum but we are not able to get, so we are going to reduce this one, not this one. What would be the naive approach? Okay, difference could be less than 10. So it's not like the difference is going to be too much. That's one thing that we can use. So if there is no time complexity or time constraint, suppose there is nothing like that, then what would be the naive approach? The naive one would be go to each and every index and say that increase this by either 1, by either 2, by either 3, or decrease it by either 1, 2, either 3. So at each step we were supposed to have at max 20 options, and which one would be valid, like that one which will come till the end, and out of all of that we are going to keep track of the maximum one. That would be one approach if there were no time constraint. Is there any better approach? For each one we are going to have at max 20, so if 20 upon n, no, into the 10, like something like that. This is into the complexity, which is way higher, so we could binary search on the answer, but what is the maximum value that we can get, and we'll never try to go beyond that. We're going to iterate over, like suppose we are supposed to get 10, So even if there is a restriction that says that we can go till 25, here it says we can go till 21, we can't always say that it will go 25. That's the thing. Yeah, there are paternal. There is a smaller one. There is a pretty big one. So suppose the largest value that can go is this one, and the smallest is this one. If this two starts to go and hit this point, then it is going to come like this. Now suppose the minimum one is this one, maybe less than that. And this one will not be the green one. The green one will be this one. Then this green one. So you can say that this is the valid one. Out of this is the answer. Restriction. This is a completely new type of problem. Let's see the summation. Okay, 3000 have been able to solve this. That's pretty high. This one. Difference could be as big as 10. these are going to be unique. Why is it so? Okay, so an index cannot have multiple upper bound. Makes sense. As much as I can, as I want, as much as I can. Then at the time of meeting, say that no, we have increased so much, we need to come to here. So whenever we'll reach this point, when we can't come till this now, we're going to keep to its back direction and we are going to check for this. If 3000 people have solved, then this should not be that hard. We're going to keep track of all the maybe maximum upper bound. Yeah, the max value. So it will start from 0 and it could go anywhere between, what could be the maximum value? 20 to the 6. So then we'll maintaining an array which will be saying that that is the maximum value that I can have at index I. Each of the max I will be denoting that. Max I of 0 is going to be 0 and all the restriction point that it is going to have. Out of all this, the minimum one will be having the minimum value and then it will keep adding the values. It will keep adding the values. Yeah. So suppose this has a upper bound of let's say 9 and it starts at 3 and these two can have a difference of 2. You'll say this can be 5. Suppose these two can have a difference of let's say 2 or 3. So you'll be saying it could be 8. Then suppose it has a difference of 3. So this is 11. Now we'll check from 9. Whenever we'll be getting element greater than any other upper bound, let's say this is 10. So we will now start from here and start going to its right. We'll start going to its left. Check how many differences is there. That way, let's say there is 5. became 14, from 11, and suppose that became 19, but when we'll come here, what should be the value? Suppose this difference doesn't match, then what happens? If this 2 doesn't sum up to a, then what are we going to do? So we should start with the one that has a very low difference. So this question is like that: you have a lot of rings and you have a thread. You have a thread that could pass the ring, but the thing is that this thread has a very minimum length. Suppose this one starts at here. So you would like to keep pass the thread to some value, and from here that is what you are supposed to do. This is not like any typical problem. This one is different. Okay, maybe I can't solve this one. Let's see the fourth one. Okay, grid and D will be given, there will be output. We are given a string array grid of size n where each string has a length m. You want to count the number of different routes to climb grid. Each route must start from any cell from the bottom row and up in the top row. However, there are some constraints on the route. So it should start from any of this. And this should end at this. There can be some blocked cells. So here we have the option to go to here. There's 3 we have. I don't know. This is a mathematical one. But what about this one? Total 5,000 people were able to solve. That's a lot. kindness. Okay, it has been accepted. So it was a pretty easy problem, but I took a lot of time to think about this. Okay, there are still 30 seconds left. So this was the approach actually. No, this was a little wrong. So it will start from here. It will again try to go to its right, and whenever it will encounter something like this, it will again start from its right. Yeah. And suppose it has not started from its right, it has started from here, then while coming back also it will start from here, but it had stuck over here, so it will start from here, and we are going to take the minimum of, yeah, that was a pretty good problem actually. Yeah, the time has been ended. The contest is closed, so let's finish this one.